So the other thing that we want to do is add some unit tests to this code. So if we look here now at our unit test code, we can change what this class is doing to say something like extract should as well. And what we want extract to do is simply to get some data from these two data sources. And we don't really care what that data is in this case. So we're going to do some additional refactoring in order to get to the point where we can do this test. But basically, we want to have something like our extraction service. Well, first we need a method. So we'll create a method for our test, and we'll say extract should get data from invoices and employees. Make this a test. And then we can say var service equals new extraction service, add our reference. And then we want to basically, this is going to use a pattern called arrange act. So we'll say var result equals service dot, and we need to, actually we don't have that as a non-static method yet, but we will in a moment. So we'll just leave this out of here for now. And then we'll have our assert. And in our assert, we can verify that the state of the code, in this case, we'll say something like assert dot is not null, and it's going to be our result. So for now, we'll just say new object, right? So there's not much here yet. Let's go make it so that we can actually run this unit test and verify that it's doing the interactions that we expect. Now, the thing about the unit test is that it's not going to have any kind of a reference to system.data. It's not going to talk to the database at all. And the way we're going to achieve that is through the use of something called mock objects. And we'll see how those work in just a moment. Or through the use of a fake, which we could also use. So we'll show both of those. So let's go back to our program. We've got this extraction service. At this point, let's go ahead and move that to another file. And we've got our result. We'll move that to another file as well. And in our service, we can see that it's talking to a database. It's doing these two commands. Basically, it's going to need to talk to an invoice table, and it's going to need to talk to an employee table to do these things. So I'm going to go ahead and say that this is a non-static method as our first refactoring. And let's see what that breaks. Well, first off, in program, I'm going to have this be a new extraction service for that to work. And then same thing in our integration test we just wrote. And then it's a good idea to run all of our tests to verify everything still works. And they still run. So we can continue with our refactoring. So we come back to our service, which is now non-static. And we need to say that it depends on some things. So we're going to say, well, we need a constructor. And our constructor is going to say that we need an interface for, I think, something like iInvoice repository. And an iInvoice repository needs to be able to return back let's say, a data table to keep things easy. So it's going to have a data table, list invoices. We could specify the date that we want, but for now, let's leave that hard-coded. We'll do the simplest thing that works. And we'll also need a derived type of this. We'll call this a SQL invoice repository, and we'll make it implement the member. And then in here, we basically want to refactor out all this stuff that's using a connection, grab all that, stick it into our list invoices. And once we get to the point where we have an invoice table here, we want to return it. Actually, that's not quite right. We need a table there, then we need to fill it. So we'll say var table, and then we'll fill that table, and then we'll return that table. All right? Now, once we have that, we can come back in here and we can say, you know what, I need an iInvoice repository called invoice repository. I need a local variable set to that. So I've got now an invoice repository that's set to that. And I need this to work even if nothing is passed in so that my code still works the way it always did. So we're going to have a public extraction service empty constructor, which calls this and passes in a new SQL invoice repository, and then does nothing else. So this ensures that my code still works the way it always did. This is some poor man's dependency injection here. And then in our code, we only need this for each once we get our invoice table. So we'll pull this out. We need this result, and we need to say result dot invoice table equals invoice repository dot list invoices. And we can now get rid of this big using block. Next, we want to do the same thing with the employees. So we'll just do, let's get these out of our file. So we'll move this to another file, come back to our service, move this to another file, come back to our service, create our new interface for employees. So we have a public interface iEmployee repository. And it'll have a data table for list employees. Now we just need to create a derive type from that. We'll call it SQL employee repository. We'll implement the members, and we'll do the same thing we did before. We'll pull out all this code here and drop that in. And we'll need to have a table that we fill. And of course, you can see there's some duplication here that we would get rid of through methods already shown in other demos. We'll fill the table, we'll return that table, and then change our code here to take in that repository. So we have an iEmployee repository, employee repository. We're going to introduce and initialize a field, employee repository, just as we did before. We're also going to change our poor man's injection to automatically inject a SQL employee repository, so our code continues to work as it did before. And then we need to say that our code here, we have to get rid of all the SQL stuff and those closing curly braces. And we just need to say that result.employee table equals employee repository dot list employees. Now another instance of don't repeat yourself that you might notice here that I might change at some point is I've got employee repository and then I've got list employees. That gets to be kind of redundant. So it's pretty common to simply call this a list method instead. And that way you know it's listing employees because, well, it's an employee repository. For now, we'll leave it the way it is and verify that we can still run our code. It still runs. Of course, we should be also able to verify that by running our unit tests, which right now is just this integration test, and it still runs. Which brings us now back to our unit test. So our unit test, let's go ahead and rename our file. And that's good. Now we're able to actually call our service. So we'll call service.extract and get some result back. And since we didn't pass in any kind of variables in here, right now we're going to be doing the same thing as our integration test. So now we can verify result, and running this should run just like our integration test. And it does. And you can see we get all this data from our actual database. We don't really want to be talking to the database though at all. We really just want to be verifying that our methods were called. So what we're going to do is we're going to create a fake repository for invoice. So we'll say public class fake invoice repository inherits from iInvoice repository. And we're going to implement that member. And in this case, we just want to verify that this was called. So we're going to return a new data table with nothing in it, but we're going to have a Boolean here. So have a public bool was called equals false. And then we can set was called equals true. We'll do the same thing for our employee class. So we'll have a fake employee repository, which inherits from I employee repository, implement its member, and here we'll say was called equals true, return new data table. Now in our unit test, we can pass in these particular repositories. So we'll say var invoice repository equals new fake invoice repository, var employee repository equals new fake employee repository, and we'll pass these into our code now. This is using the strategy pattern to inject these dependencies. And then once we go to assert, instead of asserting against the result, this is called state-based testing, where we're testing that the state of our system is what we expect. What we're going to be doing is something called behavior-based testing. We're going to verify that the code under test, this extract method, did the things that we expected it to do in terms of its interactions with other code. So all we want to assert here is that invoice repository dot was called, and assert that employee repository that was called as well. And now we can run this test. And you can see that it ran in 3 milliseconds and came back as true, showing that these two things were in fact called, and it did not talk to the database. So that's an example of refactoring our code to allow for behavior-based testing. Now, if we looked at our service again and said that maybe based on the invoices, we would or would not call the employee table, we could see how that might change our unit test. So we could say something like if result.invoiceTable.rows.count equals or greater than 0, then we expect to call this. This is the kind of logic that we would be testing with our behavior-based test, because now we can come back to our unit test, and we know that we're passing back an empty data table for invoice, so we're going to expect this to be false in that case. So now we can run this unit test and see that it does what we expect. So that's an example of how we would test the behavior of the method under test, the extract method, separately from what the actual data is that it might be returning. And that wraps up our changing of static to instance methods, as well as some refactoring to get these interfaces. So we can move this interface to another file, go back to our service, move our repository to another file. And then before we're done here, let's look at what we have. We've got now our program has gotten a little bit smaller. It no longer has the extraction stuff in it. Instead, it's using this extraction service. We've got a couple of invoices, which we'd probably move to a separate folder. We have a couple of implementations of those interfaces, which we would probably move to a separate folder, or ideally to a separate assembly that would be responsible for our data access. And now we've got both integration tests that talk to the database, as well as unit tests that verify the behavior of the particular method that we're looking at.